So there is one thing that yesterday I didn't mention with you that I really want to make sure you guys double check with these, because there's a chance, wink wink, that on a quiz I could do something to really jack you up. Side, side, side case. Is it automatically one solution? Or can you have a no solution side, side, side case? I know you can. You can have a no solution. How do you have a no solution case with side, side, side?
Biggest angles are opposite of big side.
No.
The two angles are bigger than the bigger.
Is this possible?
No.
Why not?
They won't be bigger than 30.
Right. Yeah, so remember, the two small sides have to add up to be bigger than the biggest side, right? So be careful with that. Double check that kind of thing. You know, that's one of those basic checks that you should always pay attention to. If you don't realize that this is a no solution, right? Keep in mind throughout this whole chapter, the nice thing about these is they almost help double check themselves. Because let's say you didn't realize this triangle does not exist, right? And you say, I'm going to start solving it. Well, side, 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 I have to use law of cosines, right? Ricky Bobby says, which angle should I try to find? There isn't a first one. The biggest one, right? Ricky Bobby says the biggest angle is the problem. So I either do the biggest angle first or save it for last. So let's get it out of the way and find it first. So we say, all right, 30 squared would have to equal 12 squared plus 16 squared minus 2 times 12 times 16 times the cosine of C, right? Great. What do I type in my calculator? Come on.
30 squared minus 12.
So first I got to make sure I'm in degree mode. Okay, so then I would type in 30 squared minus 12 squared, right? Minus 16 squared. Get that answer. And then I have to divide that by the quantity of what? The negative 2 times 12 times 16. Yes? And then I inverse cosine. When I press enter, this is going to give me an error. Why is it going to give me an error? Because it's less than negative 1. Does sine or cosine ever get above 1 or lower than negative 1? No. When mathematically, did we do anything wrong here? No. I didn't do a single thing wrong to this problem. What I did wrong was I didn't realize that this triangle is impossible. Again, one of the hardest things with this chapter is actually self-confidence. When you get an error, don't just immediately think, oh, I did something mathematically wrong. No, you're probably trying to find a solution that doesn't exist. So go back and double check how many solutions should I have here. And that's probably where you made a mistake. All right, so what was this question originally? This was 19? All right, so this is number 12, right? So the only difference is I should put a 19 there, right? So again, Ricky Bobby says I should try to find the biggest angle first. Is this triangle possible? Yes. Remember, angle C is the only one that has that possibility of being obtuse, so we get it out of the way first. So again, I grab my calculator, and the only thing I have to do differently is instead of 30 squared minus, I'm going to do 19 squared minus the 12, right? Yes? And then I want to take that answer. I've already typed this in. I can just go out and grab it and bring that whole thing down. Take the answer and divide by that. And redo it for me. A little time saver. Divide by the negative 2 times 12 times 16. And then I inverse cosine. And I get 84.1. So this answer is 84.1. So far so good? Now what should I do? After solving for C and getting that 84.1 degrees, what's the next step? Can I switch to the law of sines? Does it matter at all now of which one I do? So I do sine of this is to this. I can find A or B. Does it matter at all in this case? No, because I've already got the biggest angle out of the way. So I can do sine of A is to 12. I can butterfly that. I can do 12 times the sine of that 84. Remember, never type in around the number. Get that answer, divide that by 19, and then I inverse sine. Even though I'm inversing, I know I don't care about the second solution. Don't have to worry about it. Angle A is 38.9. So this is 38.9. And what's the easiest way to find the last angle? 180 minus. 180 minus that 38. And then minus, I go out and grab the 84. So you should get 56.9. I will warn you guys, and you know, I understand this as far as when you take your test and turn it in, you know, there is a little bit of leeway with these. It's not surprising when I see you guys get answers sometimes that are close. Like, honestly speaking, you guys should already have this problem done, right? How many of you got exactly 56.9 for this answer? Did anybody get something that's close to that? What'd you get, Owen?
I got 57.
You got 57? All right, so you rounded to 57. Anybody else get anything like 57.1 or 56.4, something like that? Well, I know, like, how would you have gotten something that's kind of close to this? Yeah, if you're using rounded numbers, you're going to get an answer that's close. Most of the time, or all the time, when the numbers are small like this, it's not really going to make much of a difference. But you need to understand, when the side lengths get bigger, for example, take a skyscraper, for example. Just a basic skyscraper, okay? Is it important that this angle right here with the ground is a 90-degree angle? Is that an important thing?
Yeah.
That's huge, isn't it? What if they build a skyscraper and that was 89 degrees? They were only off by 1 degree. What?
Turns into the leaning tower.
So what happens, so let me draw this a little bit skewed just to show you. Let's say, I know this is not 89 degrees, but it's going to demonstrate the idea, okay? So let's say this is my building, and it's only off by 1 degree. How tall is a skyscraper? Ballpark. 5,000 feet? I think that's a little tall. 5,000 is a little tall. Probably, yeah, I'd say 1,000 to 2,000, maybe somewhere in there. Let's say it's 2,000 feet tall. My question to you, how far out in the midair would you be if you were on that top floor? Basically, it'd be the same as this distance, wouldn't it?
Yeah.
How big is that distance? Well, this is a right triangle now. From here, that's opposite, so let's say I want to find, I know this angle, that's hypotenuse, this is adjacent. What's cosine of 89 x over 2,000? What is cosine of 89 times 2,000? 35 feet? So you're basically 35 feet that way. I should be here. You're 35 feet. Think about how this room is 25 feet long. So basically it'd be the difference of, if I'm on that top floor, I'm kind of into, just barely into that other classroom. But I look over, and that's where I should be, because I'm basically in midair. Like, there's nothing below me. And then the building should be over there. Like, that's a problem, isn't it? One gust of wind, and that building's probably coming over. So that's why it's so important for buildings like that to be perfect. But at the same time, this also demonstrates how when the sides get bigger, a little variation of your angle measurements, like when you use a rounded number to calculate something, it ends up making a big difference. You're not off by 0.4 or 0.1 or 0.2. You're off by 12 or 13 or 14. So, be careful with those, especially if you're dealing with a problem that has big sides. Try really hard not to round your answers, okay? Any other questions on this stuff? Yes? 18? Sure. So what'd they give us here? Angle R is 45. Side P is 13. Side Q is 19, right? Okay. Side angle side. So which law of cosines should I use? I know angle R, so I have to have the one that starts basically with R squared. So I don't know side R. Well, that's going to equal 13 squared plus 19 squared minus 2 times 13 times 19 times the cosine of 45. And again, when it's side angle side and you know everything's on one side of the equation, I'm solving for R here, which is basically already is, I would just type that whole thing in one line. And actually the first thing I would hit is the square root button. And just type all that right underneath the square root. So 13 squared, 19 squared, minus 2 times 13 times 19 times the cosine. Be careful, because this is kind of the first real homework assignment other than the SOHCAHTOA stuff that you're using the sine and the cosine button. Like, it's not just the sine button over and over. It's not just the cosine button over and over. You're kind of going back and forth. Be careful of which button you're hitting. Okay, and there's your answer. So R should equal 13.44. Now what? Can I switch to the law of sines? Yes. Do I have to be careful? Yes. I can do sine of 45 is to that 13.44 as, now should I do P next or Q next?
P.
Why P?
That's not
Because Q's the biggest, right? And again, Ricky Bobby, first or last. I can't find this first because I've already been given one. So I have to save this one for last, right? So we're just going to butterfly. We go, what, 13 times the sine of 45. Get that answer. Divide that by my 13.44. And now inverse sine. And again, don't really care about the other solution because I know angle P can't be obtuse. So now I have this is 43, which makes a lot of sense. Why is this so close to that angle? Because the two sides are really close. Like, this is almost an isosceles triangle, isn't it? So these two angles should be close to each other. And then I just subtract. So 180 minus 45, and then minus my 43, and I get 91.9. If you would have not done P second, if you would have tried to do Q second, you would have gotten an answer of like 89 degrees here, which would absolutely be wrong. Okay? So you have to be careful. In fact, this is one that I actually had to write in the textbook. There's a lot of typos in this book. This is one that the author of the book actually did wrong. The answer key's wrong. So if you look this one up in the back of the book, which you can't because it's an even, the answer to that one is actually wrong because what they did wrong was they found that answer second. It just doesn't work. Okay? Well, you know, everybody makes mistakes. It happens. But if you ever look at any math textbook and there's multiple editions, like there's a second edition and a third edition and a fourth edition of a textbook, the reason is typically is, you know, in the first edition there was some typos, so they fixed a bunch and they republished the book. And then there's still a few more, so then they fixed a few more. That's usually why there's different editions of math textbooks. So. All right. Any other questions on the law of cosines? Yes. 18? That is 18. I just did 18. That would be a big problem. So make sure you're copying the problem down. Anything else?